Selamünaleyküm.
Alaikum Mustafa. How are you?
I'm good. How about you?
I'm good. Mustafa, do you have brother?
No, just two older sisters.
Who are your sisters?
Nesibai Kaç and Husnai Kaç.
Oh, you're Nasiba's brother.
Yes.
I see. Then I confuse you with another student. Yeah. Okay, I see. Because I had also another student. Maybe he's your friend. I forgot his name. What's his name? Hmm, You know Yavuz? Yavuz Bilo?
Yavuz. Yavuz Bilal. What grade is he?
11. 11 or 10?
I don't think I know him.
Okay. Mustafa, right now, I don't know your level, but if you're like your sister Nasiba, Nasiba is very smart and very hardworking. So the more you teach, she can learn more. Okay, because your mother told me that, can you study Algebra 2 and SAT and geometry? It depends on you. This geometry, I
Mm-hmm.
mean, Algebra 2 and SAT were different, not very different concepts, but just we're going to have two lessons a week, and we can cover everything together. So now
Mm-hmm.
I'm thinking that let's start with Algebra 2, and let's see how it
Mm-hmm.
works, okay? And it's not about just being smart or not, or you can understand or not. It's about practice. But do you have time to practice? That's the most important thing. Okay, because now you're going to school and also you have some homework, right? And you have maybe projects, I don't know. And plus you need to study extra because right now you're taking geometry, right, at school.
Mm-hmm.
Okay. So what topic are you learning now? Right,
In
triangle?
geometry,
Yeah.
um,
Is it right
I don't know
triangles
the
and
topic's
trigonometry?
name. It's like lines, and then there's two like slanted lines with A, B, C, D, and you're trying to find like the difference or something like that.
So similar triangles.
Yeah.
So the similar triangles. I see. Yeah, similar triangles, and after that, you are going to learn uh, right triangles and trigonometry, and after that, polygons, and after that,
Mm-hmm.
conic sections, and blah blah. Okay, these topics are standard. It's not different. But usually, if you understand this algebra too, geometry must be easy for you because geometry is only the figure is geometry, and the
Mm-hmm.
rest, the calculation part is again is algebra. Okay, like again, that similar triangles given, and just you're using the ratio. So to be able to write this ratio, you need to know some properties of those figures. And after that, the rest of this problem is about algebra. You have to solve it. Solving something using equation means that you're using algebra. Okay. So what are we going to do? Now I'm going to use this worksheets, that is the kind of shortcuts. I can't teach you
Mm-hmm.
everything here because just 2 hours a week, I cannot teach you everything. So now this actually paper is organized really well. It has, discussion part and a homework part. But homework part now our priority is, the first part that is that should be taught in the classroom with teacher. We're going to do this part. And of course, if you have a
Mm-hmm.
lot of time, you need to practice every question if you have. Because the more question you practice, it will, number one, increase your knowledge. And number two, increase your self-confidence. Oh, I know that. And number three, the most important thing is your problem solving skill and speed. So you can think fast, you can recognize the question fast, right? And you can solve fast. Okay. So I shared these papers with you every time before we start the units. I'm going to share this. If you can print, it would be great. Okay. And
Mm-hmm.
just practice these questions. Okay. Now
Okay.
let's start. Right now, I don't know your level day by day. Okay. And as I say, as you know, in Algebra 2, we have 10 topics, but actually it's 11. And well, I'm just counting that's probability and statistics. But the mainly we have 10 topics. Okay. And some topics it may be short, sometimes it may be, what is it? And the most important thing is you need to have some idea. And as you practice more and more, and hopefully also your comprehension skill gets better. Okay.
Mm-hmm.
All right. Let's start then here. It is Mustafa. Um, Today is the first part, this introduction part. We should do some revision about the classification of numbers, right? Numbers, what is numbers? We have 0, 1, 2, 3, 4, 9. It's a symbol that is used to represent quantity, right? So the real numbers consist of the following sets of numbers. What do you understand from real numbers, Mustafa? What is a real number? Actually, whenever we say real number, what do you understand?
Real numbers. They're numbers you can use in an equation.
Real number
I
is
don't
any
remember.
number that can be shown or on the number line. If you can show any number on a number line, we have a number line, right? We have a number line. We call this number line and place the numbers. If I say 0, okay, Mr. Carson, 0 is here. It is 1. Okay, here it is. Square root of 2, it is here. If you can show on this number line, all of these numbers on this number line, they're called real numbers. If you cannot show on this number line, it's not a real number. Okay, like for example, you cannot show me on this number line negative square root of -1. Or you cannot show me on the number line 2 divided by 0. We don't have such numbers here, right? But 1
Mm-hmm.
we have here, 0.1 here, square root of 2 here, right? Okay, can you read this? Starting with irrational numbers.
Irrational numbers. Numbers in which the decimal form never terminates and does not repeat. Common examples are pi and non-perfect square roots.
So irrational number. Simply, what is irrational number? If you cannot write as a ratio of two integers, they are called irrational number, right? Examples are square root of 2, irrational number, because you cannot write it as a ratio of two integers. Square root of 5, square root of 7, and the pi, that famous pi. These are irrational numbers. We will see them, okay? But these things, I don't know how much you know about these things. You must know the numbers because we are going to use this very repeatedly. Rational number, integer, whole number, what is it? Rational numbers, irrational numbers. Okay. Rational numbers, read it.
Rational numbers, numbers in which the decimal form either terminates or repeats. Rational numbers can always be written as a fraction a slash b, where a and b are integers.
Okay. So simply the definition is if you can write a number as a ratio of two integers, that's a rational number. If you cannot, it's irrational number. And real number system we use with R, right? R means that it's a set of real numbers, right? So then what is real numbers? Real numbers is we have rational numbers and irrational numbers. Sometimes you can just use this with this in different way, but I'm just going to use QCAP. Okay, so together they
Mm-hmm.
form rational numbers. Like subsets of rational numbers, we have integers, whole numbers, natural numbers. Integers, negative, positive whole numbers, including zero, right? That is integer. Simply, what is integer? It's a real number whose fraction part is zero. Negative 5, integer. Negative 7, integer. 0, integer 5, integer 10, integer. And how about whole numbers? 0, 1, 2, 3, 4, 5 is a whole number, right? Because if you have a number, it has whole number, it has fraction part, right? So the whole part, it can be 0, it can be 1, it can be 2. And how about natural numbers? Natural numbers, naturally, we use to count the number of objects, right? They are 1, 2, 3, 4, 5. When we count in something, objects, we do not start with 0, we start with 1, right? That's why they are called natural numbers. Okay? All right. Yeah, you need to have idea. If somebody asks what is a rational number, you should be able to say that any number that can be written as a ratio of two integers, a over b, that's a rational number. If you cannot write like this, it's an irrational number. Okay. Now, in some books, they use Q cap. In some books, they use, let's say, I. Let me just use I for irrational numbers. Okay. So
Mm-hmm.
this irrational numbers, we use I. Rational numbers, we use Q. Set of numbers. We are just labeling this. So now sets. Okay. Irrational numbers, rational numbers, integers, whole numbers, natural numbers. What do you understand from set? What does set mean?
It means what type of number it is.
Set. What is the meaning of set?
Set, like
It's a
a
collection,
group of,
right?
yeah,
A collection of something, right? But in math, set is defined as a collection of well-defined objects. So it must be well-defined. Well-defined means that, for example, the students in harmony. Is it well-defined? Yes, because if you
yes,
pick any person, he can be a student or he may not be a student, right? But he cannot be both at the same time, right? If he's studying there, he's a student. If he's not studying there, he's not a student. That's it, right? Or the people in Houston. Is it well defined?
yes,
Yes, because if you just pick anyone, if you ask, are you living in Houston? He said either yes or no, right? But he doesn't say maybe. But how about not well defined or natural numbers? Well defined. If you just pick any number, I can tell you exactly is it a natural number or not. If you actually a set of real numbers, if you just give me any number, I can tell you exactly is it a real number or not. So that means well defined. And how about not well defined objects? For example, handsome boys in your class. Is it well defined? It's not.
no,
Maybe you are handsome for someone, but for someone you are not handsome, right? And tall people in Houston, maybe some people you may think it's tall, but it's not. Anyway, so that means that simply what you have to know is a collection of well-defined objects, right? Irrational numbers. So we use what letter for irrational numbers?
um, irrational numbers,
I, right?
I,
Irrational. So examples, square root of 2, for example, irrational number. Square root of 3, irrational number. You cannot write these numbers as a ratio of two integers. Square root of 5, irrational number. For example, pi, approximately 3.14, irrational number. And this one is e. irrational number, right? So these are examples for irrational numbers. And how about for rational numbers? We use Q for rational numbers, right? Give me some examples for rational numbers.
Rational numbers. Square root of 4.
Now, don't use square root of 4 because square root of 4 means 2, right?
Mm-hmm.
So just simple form is 2. So this may be
Okay.
2. Or 0, because 0, I can write a 0 over 5. Or 0.2, right? Or 5 over 7. Or 10 over 3. Or negative 2 over 3. So these are all examples for rational numbers, because all of these numbers, they can be written as a ratio of two integers. Like, for example, 0.2, 2 over 5, right? Okay, because if you understand this mathematical, the language, these are very basic concepts, vocabulary, you can understand topics really well because you can make connections. Otherwise, if you just memorize, but you don't know what is it, every time you need to think, like, what is it? You try to remember. Okay, integers. For integers, Mustafa, we use letter Z, okay, for the set of integers. So Z means set. It's a set in the folder. In the folder, we have all integers. We are just naming this folder as Z. Okay, this Z contains integers, right? And as I say at the top, we have already written integers. So what are the examples for integers? -3, -5, 10 to the power of 10, for example, and 3 and 5. Let's say 100. These are all examples for integers. Whole numbers, let's use W. And whole numbers, 0, 1, 2, 3, right? And natural numbers, we use N. So that is 1, 2, 3, 4. Okay?
Mm-hmm.
And it's just a
I
start.
got a question.
Yes.
What's the difference between whole numbers and natural numbers?
Whole numbers, they start with 0. The only difference is the whole number is a whole number starts with 0. But
Hmm.
natural numbers,
Okay.
it starts with 1. Because natural numbers means that, it's a counting numbers. So the counting, when we count something, we don't start with 0, right? 1. But whole number, why do we need whole number? Whole numbers are the whole part of a number, right? If I just write whole, for example, I can write 1.2, the whole part is 1. 3.6, the whole part is 3. And 0.7, the whole part is 0, right?
Mm-hmm.
And that's why actually mathematician, for in some cases, the whole number is used for, especially for when we use the whole part of a number, it can be 0. That's why actually they give a special name. That's frequently used. But natural number means that counting numbers that are used to count the number of something. Okay. The only difference is
Mm-hmm.
0. Whole number, it has 0. The only difference. And everything else is the same. Okay. And now let's practice how much you can remember. Okay. How many different types of numbers we talk about?
5.
The smallest one, the smallest set. That is,
The smallest?
yeah, the smallest set.
Smallest set.
Natural
Like
numbers.
which of the 5 would be the smallest?
Yeah, natural numbers, right?
Mm-hmm.
Because as I say here, natural numbers starting with 1. And now whole numbers, it has another new family member, right? The 0. It's a bit bigger family, right? And now integers, it has bigger family, also including negative numbers, right? And this rational numbers, again, is a bigger family. It's also including fractions, right? You understand what I mean?
Mm-hmm.
So that's why it is the smallest family is natural numbers. A bit bigger family, whole numbers. And bigger than this, it is integers. And bigger family, right, it is rational numbers. So if you look at the circle here, if you just label this smallest family here, that is natural numbers. A bit bigger family, the only difference is 0, that is whole numbers. And bigger than this, right, also including whole number, that is integers. And bigger than this, right, it is rational number. What does it mean? Every integer is, at the same time, it's a whole number, it's an integer, it's an irrational number. Every whole number is, at the same time, it's an integer and rational number. Every integer is, at the same time, it's a rational number, right? And now here we have something that is not rational, which is called irrational number, right? And all of these numbers together, we call them what? The father of this family, or I don't know, whatever we call this. We call this real numbers. Okay.
Mm-hmm.
All right. Now let's just name this quickly. These are hard questions. Name all sets to which each value belongs. Okay. Like for example, -10.
That'd be an integer.
Integer. What else? It
Whole
can be
number.
integer. No, whole number is always
Oh
non-negative,
no,
right?
wait.
0, 1, 2.
It would be rational number, my
Rational
bad.
number. What else?
Real number.
Real number. Okay. Score of 30.
30. Mm, rational number.
No. Square root is irrational number, right?
Oh.
It's a real number or irrational number, right?
Mm-hmm.
It is inside this circle, right? This small circle. At the same time, it's an irrational number. How about 1 and 7/9? Is it a real number? Yes,
Yes.
any number. Is it irrational?
Uh, no.
It is irrational number.
It is. How's it a
No,
rational
no, no.
number?
It's a rational number. Sorry. It's not irrational. It is a rational number. It is rational number, right? Because I can write this 1 times 9. 9 plus 7 is 16. We can write this 17/9, right?
Mm-hmm.
So the ratio of two integers is the rational number. And how about 24/8? Actually, this 3, right?
Yeah.
Yeah. So now
Rational number, whole number,
it's a rational
net
number, it's a whole number, it's a natural number, it's an
integer,
integer,
and real
real number.
number.
2.48,
Rational number
rational number,
and real number.
real number. -81, square root of 81. And
That
first we
would
have to
be
simplify, then do it, okay?
integer.
It is
It would be -9.
-9, right? Okay. So that is integer,
Uh, rational number
rational number,
and real number.
real number, right? Okay, what is pi minus pi?
0.
It is 0. So what do you say about
Whole
0?
number,
Whole number,
integer,
integer,
rational number,
mm-hmm,
and real number.
real number. How about square root of 16/25?
Uh, irrational number.
Because first, if you simplify, right, square root of 16 is 4, and square root of 25 is 5. So it is rational number. And
Real number.
real number. And 0.15, and this actually bar means that this 15 is a recurring number, right?
Mhm.
0.15, 15, 15.
So that'd be
Do you know how to change it into fraction?
um 15 over 100.
99.
Oh.
If you don't have a bar, it is 15/100. But this one's bar, right? Two numbers are repeating, so it's 15/99. Or if you simplify
Hmm.
this, both numbers are divisible by 3. It is 5/33. So since it is ratio of two integers, that is a rational number, right? And the real number. And how about 109?
No, normal number, whole number,
Natural number.
integer.
Natural number,
Yeah, natural
whole
number.
number, integer,
Uh, real. What was it called?
rational
Rational
number,
number
and
and
the
real number.
real number. -8/3?
Um, rational number and real number.
Mm-hmm. And square root of 7 over square root of 7?
That's integer. I mean, not integer. Irrational and
No, no,
real
no.
number.
Yeah, no. Square root of 7 over square root of 7, it is 1, right? Because
Oh yeah.
if you divide any number, non-zero number by itself, it is 1. So what is 1? It is natural number. So also this whole number, also this integer, a rational number, and the real number, right? First simplify, and after that you can, name this. Or anyway, this is just
Mm-hmm.
classification of numbers. Now let's talk about properties of real numbers. And this, Mustafa, property of real numbers, you actually have been using this since when? Third grade, or maybe even second grades. But at the time, they didn't give you a name because you don't understand at this age. But we have been using this because the whole math that you have studied or you're going to study is based on these rules. Even if you actually study algebra 2 or pre-calculus or calculus, you go to university, college, they're going to use these rules. These are the rules of mathematical life. And just now, we are just going to give a name and we are going to learn this with names. So consciously, when you're doing something, so you know that which rule you are using this, okay? So let's see how much you can remember. Let's start with one of the most important rule, that is commutative property. So do you remember this? Have you ever seen or have you ever heard commutative property? Commutative property, addition.
Oh, addition.
Commutative means that is A plus B is equal to B plus A, right? It
Mm-hmm.
means that if you are combining two things or adding two things, if you add the first number to the second number or the second number to the first number, the result does not change, right? If you go to the Walmart, if you just buy, for example, some cheese and let's say some vegetables, you pay this, or first vegetables and cheese, you pay the same amount, right? The order actually doesn't matter. How about multiplication? Multiplication is A times B is equal to B times A. And everybody said, oh, that's simple, but in application, all the people, they don't know how to use it. How about associative property? It says that if you're given three numbers, if you add first, the second, and third, or first and the second, and after that, the result of the second, third, the result does not change. And also for multiplication, A times B times C is equal to A times B times C. Now I will show you in examples how we are using. Every time you are doing math, you are using, maybe consciously or unconsciously, but you are using this. And how about identity property? Do you remember? When you say
No.
identity card, what do you understand? What comes to your mind first?
Identity. What a number is like. What identifies that?
When I say identity, it comes yourself, right? Something that
Mm-hmm.
shows you, one person, right? And also identity in math, like for example, addition. So that is A, the identity element is 0. A plus 0 is equal to A. We call this identity property of real number. Addition here. How about the multiplication? Uh, for multiplication, A times 1 is equal to A. If you multiply anything by 1, it is just itself, right? Okay. Mustafa, the first lesson, it might be a bit theoretical part, but first I have to make sure that you understand this rule, because from now on, every time we are going to use this stuff. The whole
Mm-hmm.
algebra 2, pre-calculus, calculus, when you go to college, you're going to use this thing. That's why the first lesson, let's learn the vocabulary. So that when I say we talk, right, we understand each other. When I say rational number, you should understand. When I say real number, you should understand. When I say I'm using commutative property, you should understand. Okay. Inverse. And how about for inverse? Also in real number system, for every number, it has additive inverse. Additive inverse means that for A, we have something we call this negative A. So the result is 0. Okay, so this negative A is the inverse element. A plus negative A, that's equal to 0. 0 is identity element for addition. And how about for multiplication? What do you think? An identity
Um,
element for addition, it is 0, right? Identity element for multiplication, it is 1. Now using this one, what do you think about inverse multiplication rule? We call this multiplicative inverse.
A
Mm-hmm.
times 0.
No. So 8
A
times, you
times
see,
A.
8 plus something gives us this 0, right? So 8
Mm-hmm.
times what gives us 1?
Oh,
1 over 8.
Oh.
A times 1 over A is equal to 1, right?
Mm-hmm.
2 times 1 over 2, 1. 3 times 1 over 3, 1. 4 times 1 over 4, it is 1, right? So we call this, these are multiplicative inverse of each other. In math, they have a special name, reciprocal. We call this later. And how about this distributive? You should remember this property. It's used a lot in sixth grade, seventh grade, eighth grade, especially in solving questions. Distributive property. It comes from distribute, right?
I know I've heard of it, but I don't really remember too well.
And every time in geometry course and algebra course and math, you use this.
Is it where like you take you like transfer you like if it's positive 10, you subtract
No,
negative
no.
10 from
If we have a number, and in
mm-hmm,
parentheses we have a group folder something like B plus C,
mm-hmm.
right? So how do we
Oh,
open this? We distribute A over each element, right? It's like
mm-hmm.
A times B plus A times C. Parentheses means that in daily life, Mustafa, it's a kind of folder. It's a kind of group or box. You just put something in a box, right? Or maybe in school, it's a classroom. If you announce that, okay, guys, today I am going to deliver, let's say, chocolate to my friends in this class. So that means that if you promise such thing, so you have to distribute your chocolate to every student in the class, right? Because you are saying that I'm going to distribute this to the class. But if you distribute to some students, but if you do not distribute to some students, it will be unfair. They say that, okay, you say that to the whole class, but we didn't get anything. You should understand this actually, if you learn things with analogy, so you can actually make comparison and understand the logic well. So that's why we are saying that, what is it? Distributed property, you have to distribute A over B and A over C. And how about if we have 3, for example, something like this, A times, let's say, B plus C plus D. At the time, this will be AB plus AC plus AD, right? And that is the only rule in math, Mustafa, that's used to open any parentheses. That's the only rule. In every level of math, you're using this property, these rules. We don't have any other rules. How many rules we have? 1, 2, 3, 4, 5. Okay. All right, Mustafa. Uh, let's actually have a practice this one and move on.
Can I
Name
take
the
a
property.
picture of
Yes.
that top?
Huh?
Can I take a picture of the properties so I can study them later?
I can share this thing with you.
Oh, okay.
This is recorded. I'm recording this. I'll save this and I'll send you the recorded video on YouTube. Only you can watch it, nobody else. And
Mm-hmm.
also this notes I'll share with you.
Okay.
And sometimes I ask you to take a note, but these things just try to understand. And we are going to use them repeatedly, not only one time. That's why, and also I'll share this with you. Okay. All right. Name the property. It says, how many properties do we have here? Commutative,
5.
associative, identity, inverse, right? And that's it. So name that property. Look at the first one, 13. What property is it?
Uh, associative.
Associative, multiplication, right?
Mm-hmm.
Okay, 14.
Um, distribution.
Uh, can I
I
just
mean,
name this like this?
distributive.
It will be easy for us. This one is number 1, number 2. Oh, okay, I think it will be a bit confusing. No problem. Excuse me. So this one is distributed property, right?
Mm-hmm.
Okay, 15. A plus minus A. You remember?
I forgot the name, but it was the
Inverse.
third one. Yeah, inverse.
Inverse, right? Inverse addition, right? And how about 16? 3A plus
Um,
2B, 2B plus 3A.
commutative.
Commutative.
Yeah, commutative.
Commutative, right? Commutative. Commute means that to go somewhere and usually just come back right by bus. You go to your work and come back. So you commute from home to work. I think it comes from that word. So that is commutative. Okay. 17. A plus B plus C equals A plus B plus C, right?
What was it called?
Associative, right?
Mm-hmm.
Associative addition. Then how about 18?
Inverse. No,
Inverse.
not inversive. What was it?
Yeah. Inverse
Yeah.
multiplication, right?
Mm-hmm.
Okay. 19,
What was the jumping distributive?
distributive. Okay. 20,
20. Uh, in.
A plus 0 equals A, right?
Mm-hmm. It was. I forget. It was like the either
Yeah.
the third or the fourth one.
ID card, identity.
Yeah, identity.
Identity, property of addition, right?
Mm-hmm.
Okay. Read the next question.
Negative eight. Oh wait. Name the additive and multiplicative inverse for each number. Additive, multiplicative.
Yeah. Name the additive and multiplicative inverse of for each number. So for additive, what is additive inverse of negative 8?
Uh,
8, right? Because 8
eight.
plus negative 8 is 0.
Mm-hmm.
How about multiplicative?
Um, 1/8.
1 over negative 8. Because this one is A plus negative A is equal to 0. Next one is A times 1 over A is equal to 1, right? So
Mm-hmm.
our A here is negative 8. So that is 1 over negative 8. And 22, additive,
-2/3.
negative 2 over 3. Okay. And multiplicative, two over 3 times what number equals 1?
3/2.
3 over 2. So it is multiplicative inverse is 3 over 2. In general, Mustafa, multiplicative inverse of A over B is B over A, right? So that's equal to
Mm-hmm.
1, right? Okay, 23,
23. Additive would be -6W.
multiplicative,
Multiplicative would be 1/6W.
uh-huh. Additive, 24.
Do I simplify first?
No, you don't have to.
Okay, then um negative the square root of 10.
Negative square root of 10. Okay. And multiplicative inverse,
Negative 1/square root of 10.
1 over square root of 10. Okay. That's it, Mustafa. These are basic things, but the whole math, for about more than 1,500 years, they have been using these rules. The whole
Mm-hmm.
math is based on these rules. You go to a college, you're going to use these rules. You are taking calculus, you're using these rules. You are taking linear algebra, you're using these rules. You're taking differential equations, discrete math, you're using these rules. The whole math is based on these rules. That's what called fundamental algebra, the foundation of algebra. The whole algebra is based on this. So now let's actually talk about another concept. Okay, and after that we'll practice with what is it? Equations and expressions, something else. Okay, these are just basic vocabulary. Closure property. Okay, first read it and after we'll discuss. First, can you read it? What is closure property?
Closure property. A set is closed under an operation if the
What
operation
operations do
all
you know? Mustafa, what operations? What do we mean by operations?
like the problem
Hmm?
that we're trying to solve.
Under an operation means what?
When we're trying to
We have four operations, right? Basic operations. What are they?
mhm,
Addition, subtraction,
addition, subtraction,
multiplication, division.
multiplication, division.
Operation means this. If
Mm,
you are adding two numbers, if you are subtracting one number from another number, if you're multiplying two numbers together, if you're dividing a number by another number. So that's it. Operation means this. In math, we have four basic operations. And
Mm-hmm.
later we will learn more operation, but they are in advanced math. But in high school, we have four basic operations: addition, subtraction, multiplication, division. When we say that a set is closed under an operation, so that means that if you just take two numbers from a set, right, in the folder, if you add or if you subtract or if you multiply, if you divide, it means this. Continue.
If the operation always produces an element of the same set, if an element outside the set is produced, then the operation is not closed.
Okay, now let's try to understand. Okay, you have a folder or something. Okay, so if you just add or subtract, or for example, natural numbers, two natural numbers. If I say natural number, is it closed under addition? So that means that if you just add two natural numbers, the result will be a natural number.
Yes?
Yes, always, right? That means that natural numbers is closed under addition. It means this in math. And how about subtraction? Is the set of natural numbers closed under subtraction?
No.
No. Example, can you give me one counter example that negates this statement?
2 minus 2 equals 0.
Right? It is zero is not a natural number. That means that it's not closed under subtraction. Or 2 minus 5 is negative 3. Negative 3 is not a natural number. Very good. You got it now. Now read question 25. Answer true or
Integers,
false, right? If false, give a
mhm.
counter example. Okay.
Integers are closed under multiplication.
True or false?
True.
It is true. If you multiply any two integers, the result will be integers, right? So that means it is true. It's always true. 26,
Irrational numbers are closed under subtraction. That's false.
counter example.
Mm, uh,
Pi minus pi. Is pi a rational number? Yes.
what?
Pi
Oh, yeah.
is a
Hmm.
irrational number, right? And what is pi
Yes.
minus pi?
0.
Zero. Pi is an irrational number, but when you subtract this, we get a rational number. Zero is not an irrational number, right? So this
Hmm.
zero is, what is it? It is a rational number. That's a counter example. It's 27.
Whole numbers are closed under division.
True or false?
That's false.
It is false. Give me a counter example.
7 divided by 5.
7 divided by 5, right? It is not a whole number. 7 is a whole number, 5 is a whole number. 28.
Odd numbers are closed under addition.
If you add two odd numbers, do you still get odd number? Mustafa? Hello? Mustafa, can you hear me?
İnternetim gitti de.
Okay.
Odd numbers are closed under addition. That's true.
False.
False?
If you add two odd number, for example, 3 is an odd number, 5 is an odd number. If you add this, we don't get odd number, right? We get even number.
Oh,
So that is not even. This 8 is not even.
I thought it was talking negative numbers.
Odd numbers. Okay, Mustafa, these are very basic and we're going to use. And sometimes I ask you, what properties are we using? Again, this
Mm-hmm.
homework parts, if you have time, do it. If not, let's try to learn more
Mm-hmm.
things. If you understand this one, it will be enough. But actual homework is okay. We have 10 minutes left. Let's talk about order of operations. Okay, so
So are these classes 1 hour long each or 2 hours?
50 minutes.
50 minutes?
Yeah, 50, 55.
Hmm.
But if I don't have class after you, we can have 1 hour. But if I have class and just need short break, 2-3 minutes. I'll finish at 55, but usually 55 minutes because usually I have class, I need to
Mm-hmm.
finish it and after that close it and open Zoom again and start the next class. So I don't want to be late for the other class. But 3-5 minutes is not a big problem.
Mm-hmm.
Mustafa, let's do some questions. Okay, after maybe 3-4 minutes, we'll just do some discussion summary and finish the class. Okay. So
Okay.
now order operations, it's also very important because in real life, everything has an order, right? Even
Mm-hmm.
like, for example, if you want to eat a fried egg, what do you do first?
You crack the egg open and cook it.
Really? First,
You
we go
get
to the
that.
kitchen,
You
right?
buy the egg.
Yeah, you go to the kitchen, right? Suppose you're in the
Mm-hmm.
house, right? I mean, of course, we
Mm-hmm.
can ask a lot of things, but first we go to the kitchen and put a pan on the oven, right? And after
Mm-hmm.
that, crack or put some oil first, right? Then we crack eggs, right? First, we have to heat the
Mm-hmm.
oil. So that is the order of operation, right?
Mm-hmm.
Okay. And for example, if you go in the morning, you just wake up, what do you do? First, we go first to the bathroom, right? And you wash your face and hands, right? And after that, maybe teeth, right? Blah, blah. It has a certain order. Also, when we take abdes, right? Wudu, it has an order, right? Because order matters. And also in math, we have order of operations, right? In math, we call this what? They have a special name. I don't like this kind of names, but sometimes it's good. What is that? P, E, you remember? M, D,
Oh, PEMDAS.
PEMDAS, right? So that means that
Mm-hmm.
parentheses, exponents, multiplication or division from left to right, whichever comes first, and addition or subtraction from left to right, whichever comes first, right? So
Mm-hmm.
that's it. Order operation means the math this. If we have a bunch of parentheses, we should start with the innermost parentheses, right? And step by step. Okay, that's it. Now let's do this. Okay, let's do quickly. How many questions? Let's do 4 questions and finish the class. All right. Now just explain, tell me what to do. I'm going to write it here. Okay.
Okay.
Look at question 1. Do it.
All right. First, it would be 2 to the power of 3. So 2 times 2 times 2.
Just say 2 cubed, right? It is 8. Okay.
Okay.
And
And
11 minus
then
8.
11 minus 8. And
It's
then
3, right? Just calculate. Just say this 3.
mhm.
Plus,
Oh, like
next.
just do it like that? Okay.
Yeah, because how am I going to do this? Okay, I have parentheses, so I'm going to
Mm-hmm.
simplify this, right?
Mm-hmm.
And now I have exponent division. I'm going to simplify this at the same time.
Mm-hmm.
And after addition subtraction. So what is 6 squared divided by 4?
So 6 times 6, 36 divided by 4 would be 9.
Okay. So what is the result here?
Now from left to right. So 29 minus 3, which gives you 27,
26.
plus 9, which is,
26.
oh, 26, my bad. 26 plus 9, which gives you 35.
35. That's it. Next.
Um,
What is 4
are
cubed?
those two lines exponents?
No, no, no. This 2 lines is absolute value.
Okay.
You know, what is absolute value? What is absolute value of A? What
Hmm.
do we mean by this?
Absolute value of A should be A.
It is a distance, right? Between
Mm,
A and 0. If we have like absolute value of 3, so that means what does it mean? Algebra means it's like labeling things, right? Absolute value of 3 means that what is the distance between numbers 3 and 0? So how far is 3 away from 0? It is 3 units away,
3.
right? And how about
Hmm.
absolute value of -3? Also, it is 3 units
3.
away from 0, right?
Hmm.
It's a distance. That's why it's always non-negative. It may be 0, but it's 0, 0. Otherwise, it's always positive. So let's start from here. Every step we simplify. 4 cubed is 64 minus
Hmm.
absolute value of 8 is 8. 8 times 6 is
Hmm.
48 and divided by 16 equals 64 minus 48 divided by 16 is 3. And 64 minus 3 is 61. Like this. If you can do like this, that means that you mastered that skill. Okay. Two more questions.
Okay.
Three.
5 times 5, that's 25. And then
Uh-huh.
2 plus 25, that's 27 minus 7.
First, 10 minus 12 is negative 2. Absolute value of, yes, 20, you said 27, right? Very good. 27.
Mm-hmm.
Okay. And at the bottom,
Um, 2 times 2 is 4 minus, that's bottom is 5.
so it is 5. Okay. Next.
Mm-hmm. Um, 27 minus 7 minus 27 equals negative 20
Mm-hmm.
over 5. And that can be simplified into negative 4.
Okay. The last one?
2 minus 3, 2. So that'd be 3 times, no, you first,
Yes, 3
does
squared,
the
right?
3
Exponent.
square, which is 9,
Yeah. What is negative 2 minus 9?
2 minus negative 9 would
2
be
minus 9. It is just 2 minus 9,
negative,
right? Negative 7.
yeah, negative 7,
Negative 7 squared and plus square root of 81 is 9.
9.
Favorite step, try to simplify. 10 minus 6
So
divided by 3 is 2,
that's
right?
2.
Okay.
Hmm.
Now simplify the top.
Um, 2, you put 2 in. So negative 7 times negative 7 would be 49
Ibrahim,
plus
now you're
9.
algebra 2. Okay. In sixth grade, seventh grades, when you are calculating a squared, so it is a times a, and then calculate this. Okay. But algebra 2, just say that negative 7 squared equals 49. Don't say that
Hmm.
negative 7 times. And for the first time you're learning, you have to practice to understand this. But now you're taking algebra 2, just say negative 7 squared is 49. 49 plus
Hmm.
9 is 58 over 8 minus 2 is 8. Now both numbers are even numbers. Divide by 2, 29 over 4. Or in decimal form, that is, what is it? 4 times 7 is 28. That is 7.25. Okay, no problem.
Hmm.
Mustafa, that's all for today. I shared the link that is from Hunt Academy.
Hmm.
Okay, that is of course optional. I'm just suggesting it if possible, if you have time. And because what I feel that you are taking this lesson seriously, that's why you're going to prepare and take this algebra 2 exam, right? And
Hmm.
also I remember my age. How old are you now?
I'm 14.
14. Very good. Also, when I was 14, exactly when I was 14, I was going to ninth grade. In eighth grade, I didn't go to school for 1 year. It was a huge gap. And ninth grade, first quarter, I didn't go to school. And after that, my mother just pushed me, you should go and study. But I was a very good student. And when I continued my study because I moved to the capital city of Uzbekistan, Tashkent, and the new environment, new people, I didn't understand anything, even how to simplify fractions. And after this, my brother, he just told to arrange one private tutor as a professor at university. So I just attend to his house like 3 times or 4 times a week. We're just sitting on a table face to face, explain. And once I got, interested, I loved math. And I started, I think, in November, yeah, November, December, and until May or June, because in June we have, you know, university exams, but I was at in middle school, ninth grade. So in 6 months, I learned everything from, let's say, this fifth grade math to 12th grade math. But 6, 7 year math, I studied only in 6, 7 months. Okay, and you may think, how is it possible? Math is not something that you have to read everything. Once you understand the logic for an equation, you can solve every equation. Just learn the concept, and you can do this. Because every time, as I told you, we are going to use these properties. These properties are used in everything, but just in different form. Maybe we have x, and after we have sine of x, maybe we have logarithm of x, but idea is the same. Okay. So if you take this seriously, in 6 months, we have maybe 4 months, you can learn a lot. But of course, it depends on your self effort. If you just make effort, study every day, the more you learn, you will see that you get more excited and also you actually get more interested. I mean, you get interested more in learning. Okay, that's what actually, Also, Allah says in the Quran, the only thing that tells us to pray to increase something, right? What is that? Increasing our knowledge, right? So Rabbi zidni ilma, right? But just making dua. I'm hoping that if you take seriously, you are going to learn a lot. Okay, I'm here to teach everything. I teach at I teach at a college, university. I taught middle school student, high school student. I train students for math Olympiad. Whatever you need, I can teach you. But just one way is not enough. Also, you need to practice. You need to make effort. If you come with questions, we can actually have very good, fruitful. What is it? We can learn a lot. Okay, it depends on it. All right. Okay, Mustafa will continue to talk. I will see you next Monday, right? I'll
Mm-hmm.
share with you, if possible, as many questions as you can to solve it. Okay.
Okay.
Do you have any questions?
No, not really.
Okay. Have a good night. See you next week. Okay.
You too.
Bye.
Bye.